Now we're going to move on to managing orders for the exchange. We're going to hit the next items on our development checklist, which are to make an order and cancel an order. So basically, we want people to make orders on the exchange, add it to the order book after they have deposited tokens or deposited ether. They're basically going to make an order that says either I want to purchase tokens or I want to sell tokens, right? So we'll talk about how that works as we implement it. And we also want to be able to cancel orders, okay? There are a few things we need to make an order. First, we need to basically model an order, all right? And then we need to store an order on the blockchain with our smart contract. So essentially, this exchange smart contract is going to act like a database for all the orders in our order book on the exchange. Well, the blockchain is going to act like a database, but the exchange smart contract is going to act like the interface for that exchange. Okay, so we need a way to model the order. And we need to store the order. And then, or a way to. And a way to model the order. And we need to add the order to storage. All right, so it's three things. We need a way to model the order. We need a way to store the order on the blockchain. And we need a way to add the order to storage. And I guess also retrieve it from storage. So we'll figure that out in a second. So how will we model the order? We're going to do this with something called a struct. Solidity allows you to create your own data types with something called a struct. And we can create a new struct like this. We can use the struct keyword, struct. And we can create a struct called an order. All right, I'm going to use an underscore here. And you'll see why we're going to use underscore later. For now, just trust me. And basically, this is going to allow us to model the order. We'll create a new struct that has some attributes. It tracks the order ID and other attributes about the order, like the user who made it, the token they're trying to purchase, how many tokens they're trying to purchase, all that kind of stuff, okay? So we can add the attributes to the struct like this. We can, give the order an ID. We can say uint ID. And this ID isn't going to be like magically generated for us or anything like that. We're going to have to generate it ourselves, and I'll show you that. But we can also add some other attributes. So I'll go ahead and fill those in right now. So here's all the other attributes of our order. So like I said, we got an ID. The order is also going to have an address of a user address. And this is going to be the person who made the order, the person who actually, basically created the order. And we're also going to have an address of the token they want to purchase, right? So token get, right? We can see that here. And the amount of tokens they want to get. And the token that they're going to use in the trade, right? So the token they're going to give and the amount they're going to give and the timestamp. This is going to be the actual time that the order was created, okay? And that's all that we need in order to store this order. It's sort of like creating an object that's going to go into our database, so to speak. All right, so that's how we model it. Now we need a way to store it, okay? So we're going to store the order on the blockchain with a mapping, just like we did with these other mappings in the exchange and the token. And we're going to call this mapping orders. So just below tokens, we'll say mapping. And then we will say uint 256. Oops, sorry, 256. And we'll call this order. Then public. Okay, so in Solidity, we express the type of the key and the value. So the key is going to be an ID, it's going to be an ID of type uint 256, and the value is going to be an order struct, which you defined here, okay? Like I said, Solidity allows us to define our own types. Here's our new type, and this is the value, which is the type that's being returned. And this is public, and it's going to be a mapping of orders. So we'll get a function here for free from Solidity that allows us to read all the orders out of this mapping. All right. So that's how we model the order. This is how we store the order. All right. And now we need to add the order to storage. So we're going to create a function that creates new orders on the blockchain. So we go down here below balance of, and I'll create a new function. we'll call this make order. So function make order. And this is going to accept a few arguments, just like, corresponding to our order attributes. We're going to say address of the token we want to get, and then the uint 256 amount get, and then address token give, and then uint amount give. And that's how you create a new order. We basically pass in the attributes that we want for the order struct. Okay? So what we're going to do is basically create a new order with this struct with all these function arguments, and then add it to this orders mapping that we just defined. Okay? There's some more things we need to do inside of here. First, I'll show you how to instantiate the struct. Okay? How to basically, instantiate a new order. We'll say this. We'll say order is going to equal a new order like this, order. All right. Then we're going to pass in the attributes. So we'll say ID. So we don't have an ID yet. Let's just say ID equals 1, just to kind of mock this up. ID. And then msg.sender is going to be the user. And then the token get is going to be token get. And then token get amount get. And then token give. And then amount give. And then last attribute is a timestamp. So we want to express a timestamp in Solidity for this order, like when it was created. And Solidity allows us to do that with now. That's really nice. So it's very simple, very self-explanatory, but this will actually pass in the current timestamp of the order. Now, in Solidity, this order is expressed in seconds. It's expressed in epoch time. So here's an example of epoch time. This is a Unix convention that is basically a timestamp since a certain time point in history, and it's expressed in seconds. So here's an example of an epoch timestamp, and you can look at epochconverter.com to see examples of this. So this is the current time for me in epoch time. All right, so that's how you instantiate a new order. All right, now we want to add this to the orders mapping, but we need a couple more things first. We need a way to generate IDs. So how do we do that, right? Well, we can keep track of all the orders that have ever been created inside the smart contract with a counter cache. And then we can use that counter cache to, update that anytime a new order is created, and then use that to generate IDs for the orders. Okay, so I'll create a new counter cache at the top of our smart contract next to our other variables. So just below orders, I'll say uint 256 public order count. All right, and that's going to keep track of our orders as a counter cache. So this would be an unsigned integer. It will start as 0, and we'll just add from there. All right, so what we can do is go back down to our make order function, and instead of just using this ID as a 1, we'll actually update the count. So whatever it is now, we'll just say order count. We'll update it. We'll say order count add 1. Okay. And now we can add our newly created order to the orders mapping like this. We'll say orders order count. All right, and then we'll add it to the mapping. All right. Save that. And we can see it gets added to this orders mapping here. So now we have basically modeled the order. We've created a new one whenever we call this make order function. And we give it an ID. We keep track of all the orders that have been created, and we give it an ID. We stick in the orders mapping with this order count, and we, add the newly created order here. Lastly, we want to trigger an event anytime an order is made. All right. So we can also do that with Solidity, with events, like we've been doing in pretty much every function so far. So we're going to do this with an order event, and I'll show you what that looks like. We'll go here. All right, there's our order event. The attributes are basically identical. And you'll notice I use underscore order here. That's because of the naming conflict with the order event. I wanted to keep the order event, without an underscore. We're going to use this outside the smart contract. We're going to use this inside the smart contract only. So I wanted to keep the underscore convention to avoid naming conflicts and also let us know that this is just for internal use. All right, so I'm going to call this structs down here. And also, while we're here, I should mention, there's a little bit of inconsistency saying uint by itself without 256. This is the same thing as saying uint 256. I know it's kind of confusing. My apologies. Again, there are other types of uints like uint 8, right? But this is just a default for uint 256. In fact, I'll go ahead and refactor this right now to be more explicit. And let's see here, uint 256. All right, there we go. All right, so let's actually emit this order event anytime the order is made. So I'm going to just call it to the function like this. Say emit order. Pass in the attributes. So the order count, that's going to be the ID. Basically everything we're passing in here. The ID, the sender, token get, the amount get, token give, amount give, and the timestamp. All right. So let's write some tests for this to make sure that it works. All right. I've gone ahead and set up a scenario here for making orders inside our test suite. So basically, below checking balances, I've talked about making orders. So, we set up a result variable and we said, wait, exchange, make an order. And we want to do the token, let's just see here, the token get is the token itself, and we want 1 token, and the token give is ether, and we're going to say the amount is 1 ether, and we're going to do this from user 1. Okay, and we're going to say it tracks a newly created order. We're going to add some more steps to this, but first we just want to see that the order count was actually set to 1. So basically we can fetch the order count from the exchange and coerce it to a string, and that should equal 1, like this. Okay, so let's run the test and see what happens. Truffle tests. All right, so it looks like we got an issue here. It didn't compile, so I think I see what the problem is. So basically, we forgot to change this ID back. So we'll say order count. All right, try that again, run the test. All right, it worked. It passes. So while I'm here, I'm actually going to go ahead and restart Ganache because I think my ether might be getting low. I mean, we got plenty, but just in case your ether is like running really low at this point, I would go ahead and restart. So I'll just do it and see what happens. Let's go settings, restart. All right, we're back to 100 ether. And while we're here, let's just rerun the test, make sure we're all good. Say I'm going to specify the file instead of running all these tests. Truffle test, and then we'll say test/exchange.test.js. All right, still passes. We're good. So let's add some more tests here. What we want to do is actually examine the new order that was created rather than just seeing that the order count went up. Okay. So what we want to do is actually fetch the order out of our mapping. So in Solidity, I should mention that there's no real way to get, all of the orders out of this mapping. We can't just talk to the blockchain and say, hey, give me this, everything in here. That's because there's no way to determine the size of a mapping in Solidity. It's just a limitation of the EVM. And we actually have to fetch all the orders out of here one by one if we wanted to. So if we wanted to get all the orders inside of here, we basically have to find the size, and we would have to fetch them out one by one, right? Or we could use something like an event stream, which we'll see in the client-side project. So that's one of the reasons we have the orders count. We know how many orders are there in total, and we know that from basically 0 all the way up to the orders count, there's an order that corresponds to every single one of those integers. All right, so we can fetch the order out of the mapping by knowing its count. I can fetch the order out of the exchange smart contract like this. Say const order equals await exchange orders, and then pass in 1. And now we can actually dig into that order to make sure that all the attributes are correct. Okay, and I'll do that like this. All right, we checked that the ID is correct, that the user is correct, the token get is correct, the token give is correct, ether address, amount, and timestamp. Okay, so let's save this and run the test. All right, it passes. So next, we want to test that the order event was triggered. And this works pretty much just like every other event that we've checked for inside of our test so far. So I'll just create a new example like this, just like the other ones. All right, so we check that it emits an order event. And it should be in order. It should have the ID, it should have the user, the token get, the amount get, the token give, the amount give, and the timestamp. So run the tests. All right, it passes. Now we've finished making orders, so we can check that off the list. And the next item in the checklist is to be able to cancel orders. All right, so that's what we'll work on now. If someone's made an order, we're going to allow them to cancel so that no one else can fill it. Okay, we'll start with a cancel order function. We'll say function a cancel order, and we'll just pass in the ID. All right, I'll say public. So what do we want to do inside of here? Well, at first it might be tempting to say, hey, maybe we want to, take the order out of this mapping, like take it out of the orders mapping if we cancel an order. But that's not actually what we're going to do, okay? Anytime an order goes in the orders mapping, it's going to be there forever, all right? And likewise, anytime we cancel an order, we're going to create a new mapping where we store all the canceled orders, okay? And we'll be able to compare the two. Basically, if the order is in canceled orders, we're not going to let anyone fetch it out of the orders mapping itself. And mostly speaking, these mappings are going to be used primarily for internal purposes. These events are going to be way more important when we're building out the client-side project, which we'll see later. Basically, we're going to subscribe to event streams on these smart contracts in order to pull out the history. So that's one of the reasons that we're using this order event. We can get a stream of all of the order events that were ever created, so anytime a new order was created, and we can load up our order book that way. And we'll see this on the client side. We can take all the canceled orders as well, because we'll create a cancel event, and we'll basically subtract all the canceled orders from these orders to get the active orders. We're going to see that more in detail later. Don't let that confuse you too much right now. But just in case you're thinking ahead and wondering where we're going, that's where we're going. All right, so back to the task at hand, canceling orders. What we want to do is add this to a canceled order mapping, not take it out of this mapping. So let's create a mapping for the canceled orders specifically. All right, so let's go up here and we'll say a mapping uint 256. This will be just a Boolean, so bool. So bool is, a type in Solidity, so it's true or false. And we'll say public order canceled. All right. So whenever we cancel the order, we basically want to update this mapping. Order canceled. We're going to pass in the ID, and we're going to say true. Oops. And this will be our source of truth that determines whether an order has been canceled or not. All right. So we also want to emit a cancel event, like I just mentioned. So we're going to create one. We will copy this and put it here. So after order, we're going to say cancel. All right. And I'm going to call these uint 256 just to be consistent. And this event is going to work just like our order event. We're going to have a cancel event and an order event. All right. So down here inside the cancel function, we're going to add this as well. All right. Now we want to add some requirements to the function. First, we want to make sure that the order user is the same as the person who's calling this function. So must be my order. So if I call cancel order, I had to have made the order in the first place. And we also want it to be a valid order. So we don't want to try to cancel an order that doesn't exist. All right. So in order to get both of those, we first need to fetch the order from the mapping. All right. How do we do that? Well, like this. We say order storage order equals orders and say ID. Oops, ID. All right, let me explain this. So we're passing the ID. We are fetching the order out of the mapping, and we're telling Solidity that this is going to be a variable called underscore order, and it's going to be of order type. And we want to fetch it from storage specifically. All right. So that's what we're doing. We're fetching it out of storage from the blockchain with this mapping, and we're assigning it to this local variable called order. All right. So now we can ensure that the order user is the same as the person calling this function, like this. We say require address, the order user, order.user is equal to msg.sender. And if it's not, we do not want this function to execute anymore. And we also want to say that the order must exist. And do like this. So order.id, all right, the order out of the thing, must equal this. So what will happen if the order doesn't exist is basically you'll pass in some unknown number, like say 100. We don't have 100 orders yet. So if you pass in 100 to the mapping, it's going to return a blank struct. And this blank struct in Solidity is going to have 0 as a default value. And that will trigger this exception right here. All right, so that is our completed cancel orders function. So I've set up a test scenario for canceling orders. All right. And I've nested this under something called order actions because we're going to do more than just cancel the orders inside of here. We'll do it later, but I've gotten us started. So you can see, we've got making orders, and then we're going to say describe order actions. We've got a little before hook here, and then we've got cancel orders. An additional describe that says success and then failure. We'll fill in failure in a moment. But for success cases, first we basically just want to try to cancel the order and make sure that it was canceled. So we can see our setup case, exchange, deposit ether. We need to put some ether on the exchange first from user 1. We're going to deposit 1 ether. And we're going to make an order to buy tokens with the ether. Exchange, make order, buy the token address, 1 token, ether address, all right, from user 1. And then for our test example, we're going to cancel the order. And we basically just want to make sure that the order is canceled. This returns true, okay? So let's run the test. All right, it passes. We'll make sure it emits a cancel event, just like every other function that we've implemented so far. So we'll do that like this. We'll say make sure it emits event, that it's a cancel event, that the ID is correct, the user is correct, token get is correct, token give, amount get, etc., timestamp. All right, let's run the test. All right, it passes. We can see that it emits a cancel event. Now I've implemented the failure cases. So first we want to do is reject an invalid order. So if you try to cancel an order that doesn't exist, we want to fail. Right, and also we want to basically reject unauthorized cancellations. So if I try to cancel an order that I didn't create, then I also want to fail. All right, so we're going to do this not from user 1 who created the order, but from user 2. So let's go ahead and add user 2. We'll scroll up to the top here, say user 2. All right, save that. Scroll back down, and let's run the test and see if it catches our failures. So trouble test. All right, it passes. All right, now that completes our next item in the checklist. We can cancel orders. Okay, so in the next video, we're going to do the final part of our exchange where we actually trade tokens and charge fees. So that's what I'm going to cover in the next video. I'll see you there.